Are you ready to math and mole? That is what we'll be doing in Unit 8 of our studies. So, I brought out the math hat and asked our friend, Mr. Mole, to join us today. As a matter of fact, our friend here asked me to start you out with this problem. How many moles of water will be produced when 8 grams of hydrogen gas react with the oxygen in the air? Good one, Mr. Mole. Let's peek in on a couple of my students to see if they know what to do.
This one is tricky. I know about reactions and I know about the mole, but this...
It seems to be some sort of combination of the two.
Absolutely. It is a combination of the two, Mr. Mole, which leads us to our study of stoichiometry.
In this lesson, you will define the term stoichiometry, use balanced chemical equations to determine mole ratios, solve mole-mole stoichiometry problems, and solve mole-mass stoichiometry problems.
Stoichiometry. What an impressive sounding word. But it is basically just the study of the math relationships involved in chemical reactions. One of the keys to your success in this unit is making sure that you are always working with a balanced equation. You will want to review this information from Unit 6 and get help from your local teacher if you need it.
Stoichiometry is the study of the quantity relationships in a chemical reaction. Chemical equations must be balanced in order to work stoichiometry problems.
Let's look at a balanced chemical equation and see what it tells us. Take a few seconds and use words rather than numbers and symbols to write the equation into your notes. 2Mg plus O2 yields 2MgO. You should have written something like 2 magnesium atoms react with a molecule of oxygen gas to produce 2 formula units of magnesium oxide. Wow, Mr. Mole, that reaction covers a lot of chemistry. Atoms, molecules, formula units. Anyway, think about this. A mole is just a way of counting very large numbers of atoms, molecules, and formula units. So, we could just as easily have said 2 moles of magnesium atoms react with a mole of molecules of oxygen gas to produce 2 moles of formula units of magnesium oxide. It seems that the coefficients represent the ratios of moles.
The coefficients of a correctly balanced chemical equation represent the ratio of moles for the different parts of the reaction. In all stoichiometry problems, this mole ratio will be used to compare quantities of different substances involved in the chemical reaction.
Cool, huh? All that balancing we did earlier is really going to pay off now. Do you wonder how chemists knew that the coefficients represent the ratios of moles? Probably by experiment, huh? Let's do an experiment of our own to see if we can verify this information. As we watch students perform the steps of the lab, fill in the data on the table provided by your local teacher.
This student is going to react baking soda with hydrochloric acid to produce salt, water, and carbon dioxide. First, the student finds the mass of the clean, dry test tube. The mass is 19.21 grams. Now the student is adding just enough baking soda to the test tube to fill the curved bottom. She masses it again and finds the new mass to be 19.46 grams.
Before we go any further, go ahead and figure out the mass of the baking soda and fill it in your data table. Of course, you subtracted and found the mass of the baking soda to be 0.25 grams.
Now the student adds the hydrochloric acid to the test tube. Notice that she only adds 1 drop at a time, then gently shakes the test tube after each drop.
Now, as you look closely at the reaction between the baking soda and the hydrochloric acid, write down any observations that confirm that a chemical reaction is actually taking place.
The student has stopped adding drops of hydrochloric acid because the reaction is complete. Now she is going to evaporate the fluid in the test tube by gently heating the test tube over a Bunsen burner flame. It's very important that she does not let any of the fluid escape. The student will continue heating the test tube for another 3 to 4 minutes to be sure she has truly evaporated all of the liquid.
While we wait on this, let's think about the reaction for a minute. We were told that our products are salt, water, and carbon dioxide. By observation, you should have noted that something was bubbling away in this reaction. What do you think that was?
The carbon dioxide, of course, because it's the only one of the 3 that is a gas at room temperature.
So that left the salt and the water. What do you think is the result of heating the test tube?
The water boils away. Leaving behind the salt.
Precisely. So, let's get back to the lab where our students will mass the test tube again, but this time with the salt in it.
The student has allowed the test tube to get completely cooled down, and now she is massing it again. The mass is now 19.39 grams.
So, now we are ready to complete the conclusion questions. First of all, finish the data chart and find the mass of the salt. Again, you subtracted, and the mass of the salt is 0.18 grams. Now, your local teacher is going to give you time to work on the rest of the conclusion questions. You are going to find the moles of both the baking soda and the salt to find an experimental mole ratio. Then, you're going to write a balanced equation to find what we call the theoretical mole ratio. When you have completed this, I will be back to discuss your findings with you. Happy calculating! Local teachers, please pause the tape now. So, you should have found that the experimental mole ratio and the theoretical mole ratio were about the same. It's always good when our experiments match up with our theory. Right, Mr. Mole? Let's look at another reaction and make sure you understand the mole ratios before we move on. Write a balanced chemical equation, including symbols to denote phases, for the following. When elemental aluminum reacts with elemental iodine, aluminum iodide is produced. Did you get it? Now, let's look at some mole ratios. What is the mole ratio of aluminum to iodine? What is the mole ratio of aluminum to aluminum iodide. What is the mole ratio of iodine to aluminum iodide? In each case, you just had to look at the coefficients to determine the mole ratio. Now, let's try something a little trickier. If you start with 4 moles of aluminum, how many moles of aluminum iodide would be produced? You can probably figure this one out in your head, but don't. This is one of those cases where we are going to follow the method so you can see how it goes, because from now on, the problems are going to get harder. Let's start by putting our problem into the good old question mark form. How many moles of aluminum iodide equal 4 moles of aluminum? Now it's time to use the mole ratios you've discovered. We're looking for moles of aluminum iodide, and we were given moles of aluminum. Using the coefficients from our balanced equation, we will use the mole ratio as a conversion factor. Put 2 moles of aluminum on the bottom and 2 moles of aluminum iodide on the top. The moles of aluminum cancel. We multiply and divide to get 4 moles of aluminum iodide.
Now you try a couple like this one. N2H4 reacts with N2O4 to produce N2 plus water. Determine the number of moles of N2O4 required to react with 2.72 moles of N2H4. Also, determine the number of moles of N2 that will be produced from 2.72 moles of N2H4. Local teachers, please pause the tape while students work problem set 1.
Now, I'll use the mole ratio from the balanced equation to convert from moles of N2H4 to moles of N2O4. I'm going to put 2 moles of N2H4 on the bottom so that the units will cancel, and 1 mole of N2O4 on the top. Now I multiply across the top and divide by the bottom to get 1.36 moles of N2O4. The next one is